All right, guys, here we are. I'm here to go over homework number 7 with you. I'm going to go through these answers probably as quickly as I can here, but I'm going to explain each one as I go. So here we go. The first one has a negative exponent in the bottom, so that negative exponent needs to go to the top. There are 2 y's already on top, 5 more moving to the top. That gives you 7 y's on top and just 1 on the bottom, and a better way to write that is just y to the 7th, right? In the second one, both the m on the top and the m on the bottom need to change places because they both have a negative exponent. So this is really 10 m's on top and 6 m's on the bottom. And then when you go to start canceling stuff out, you'd be left with 4 m's on top, right? Over 1. And of course, a better way to write that is just m to the 4th. In the third one, the first thing I see is that there's 4 a's on the bottom that need to move to the top. There are currently 0 a's on top, so that is going to give me 3a to the 4th on top, and the only thing left on the bottom is the coefficient 1. And again, a better way to write that is just 3a to the 4th. Number 4, I am multiplying these together, so I'm going to add their exponents. This is going to equal n to the negative 4th. And of course, I want to take the reciprocal then of n, which would be 1 over n. And my final result is 1n to the 4th. The next one, I would start by simplifying the fraction, 6 over 8. 2 goes into both of those. That would be 3 over 4. With the m's, I notice that I have 3 m's on the bottom that need to go to the top. And they're going to join the 2 m's that are already up there, giving me a total of 5 m's on top. The n's, on top there's a negative exponent. That guy needs to move to the bottom. The 5 n's that are down there are going to stay on the bottom. I now have a total of 6 n's on the bottom. And there's my final result. In number 6, I need to apply this exponent to each thing in parentheses. That would give me 2 to the 3rd, x to the, and of course I have a power to a power, so I need to multiply them and get negative 9. 2 to the 3rd is, of course, 8. X to the negative 9th. And now, of course, I need to take care of that negative exponent. You know, one way to think about that would be, ooh, this is a fraction, by putting it over 1. And the negative 9 needs to move to the bottom. And that turns it positive. So my final result is 8 over x to the 9th. Number 7 just has a negative exponent, so I need to take the reciprocal of 6. It'd be 1 over 6 squared, or I could go ahead and actually do the 6 squared and get 1 over 36. Either one of these would be acceptable. In the next one, the first thing I would do is I would take the negative exponent that's on the bottom and move it to the top. That would give me, let's see, there were 3 2's already on top, 2 more moving up there. That is now 5 2's on top, and there's nothing left over on the bottom. And that, of course, is 2 to the 5th power. 2, 4, 8, 16, 32. That is 32. All right, the next thing I need is I need to take this negative exponent. There's a couple ways you could do this. One is you could turn the negative exponent positive by taking the reciprocal of the base. So I take the reciprocal of the base, and that turns the exponent positive. Then apply the 2 to each thing, and I end up with 25 over 16. And that's a good final answer. Another way to think about that is maybe you apply the negative exponent before you turn it positive. That would give me 4 to the negative second over 5 to the negative second. But of course, since both of those have negative exponents, they both need to switch places in the fraction. So the 5 moves to the top and the 4 moves to the bottom. And that gives me the same answer I got before. Number 10. Number 10, the first thing I would do is take the 10 over 15 and reduce it. It reduces to 2 over 3 because 5 goes into both numbers. With the x's, the ones on the bottom need to move to the top, right? And the ones on the top need to move to the bottom. So now I really have 5 on top and 2 on the bottom. And of course, you need to remember that when you switch it, the sign changes to positive. The y's, the ones on top are going to stay, but the one on the bottom needs to move to the top, giving me a total of 6 y's on top instead of 5. And the z's can stay where they are. I now need to simplify this fraction, and my final result would be 2/3. The x's have 5 on top and 2 on the bottom, so when I go to cancel them out, I'm left with 3 on top. The y's have 6 on top, and the z's, 1 on top and 3 on the bottom. I go to cancel them out, that's 2 extra z's on the bottom. Number 11 is very similar to number 10. We need to take the 2 over 8 and reduce it. That would be 1 over 4. So this time I'm going to talk through doing it in one step. I'm going to move the variables that have negative exponents and cancel all in one step. The a's have 3 on the top and 3 on the bottom. They all cancel out. There are no a's left in the problem. The b's, well, the ones that are on the bottom actually belong on the top, and the ones that are on the top actually belong on the bottom. And when I go to cancel them out, 5 extra b's on top. The c's, they don't need to move. They just need to be reduced. And there would be 3 extra on the bottom, of course. My answer is 1b to the 5th over 4c to the 3rd. And of course, we don't really need that 1 that's on top. A better way to write that would be b to the 5th over 4c to the 3rd. Last one, number 12, very similar to 10 and 11. I would start by reducing the 6 over 12. That reduces to 1/2. I've got a couple m's on the bottom that have a negative exponent, so they need to move to the top. That gives me a total of 3 m's on top. The n's, you'll notice the n's have 3 on top that need to move to the bottom and join the 4 n's that are going to stay on the bottom, giving me a total of 7 n's on the bottom. And last up, I got that p. That guy needs to move to the bottom and turn positive, and there's my final result. Again, we don't really need the 1 in the numerator, so let's rewrite it as m to the 3rd over 2 n to the 7th p squared. All right, let's go through the rest of this review pretty quickly. When I am multiplying terms together, I add the exponents. So this would be 3 to the 2 plus 7, or 3 to the 9th. This would be 3 times 5 is 15. Now I'm going to add the exponents, so that would be 3 plus 4, 7, 15y to the 7th. And here I've got negative 2 times 7. Negative 2 times 7 is negative 14. I've got 5 x's here and 1 x here. So that's a total of 6 x's being multiplied together. When I have a power to a power, remember I multiply the exponents together. So this would be x to the 7 times 3, or x to the 21st. Here I would need to apply the 4 to each thing in parentheses, giving me 2 to the 4th, x to the 3rd to the 4th, y squared to the 4th. Then go ahead and use those exponents. The 2 to the 4th is 2, 4, 8, 16. When I have a power to a power, I multiply them, so that would be x to the 12th. And again, same thing, power to a power, that would be y to the 8th. Last, this 2 needs to be applied to each thing in parentheses, the 4, the x to the 5th, and the 5. That gives me 4 to the 2nd, x to the 10th, over 5 to the 2nd, which I, of course, can simplify. 4 to the 2nd is 16, x to the 10th, over 5 to the 2nd is 25. Dividing terms. All right, when I divide, of course, I can just subtract the exponent. 4 to the 19 minus 8, which would be 4 to the 11th power. Or I could think about crossing them out, right? 19 on top, 8 on the bottom, cross them out, there'd be 11 left over on top. Here I've got x to the 12 minus 7, which would be x to the 5th. And here I need to reduce the fraction. 2 goes into both of those numbers. That would be 7 over 4. And then I've got 9 x's on top and 11 x's on the bottom, so I go to cancel them out. 2 extra x's on the bottom, right? Negative exponents. Negative exponents mean take the reciprocal or move it to the opposite place in the fraction. So here I might take the reciprocal, and that turns the exponent positive. And of course, that is my main goal, is just to turn the exponent positive. Here I might take the reciprocal of 2. That turns the exponent positive. If I want to go ahead and apply the exponent, that would equal 1 over 32. Here, I might think about this thing as a fraction. And because the x has a negative exponent on it, that guy moves to the bottom. And I end up with 3 over x to the 2nd. The common thing there is to want to take the 3 and move it with the x, but the 3 does not have an exponent on it, so it's going to stay where it is. Next up is the 0 exponent. These are easy, of course, right? Anything to the 0 power is 1. This equals 1. This equals 12 times 1, right? 12 times x to the 0, but the x to the 0 is 1. So this would just be 12. And this would be negative 2 times 1, or negative 2. Last problems. The 2 here needs applied to both things. 5 to the 2nd, x to the 3rd to the 2nd. That would be 25 x to the 6th. Negative 3 to the 2nd is simply negative 3 times negative 3, which is positive 9. However, this negative 3 to the 2nd is different, right? This negative 3 does not have parentheses on it, which means I do the exponent first and the minus sign second. So this would be 3 times 3, which is 9, then put the minus sign on. Negative 9 is my answer. Number 31, I need to apply this 3 to each thing. That gives me y to the 3rd over 2 to the 3rd. And if I want to go ahead and apply the 2 to the 3rd, I would get y to the 3rd over 8. In number 32, I just need to reduce the y's. I have 4 y's on top and 4 y's on the bottom, so when I cancel them out, they all go away. And I'm really just left with 5 over 1, or 5. And last up, I would want to take this and reduce the 50 over 450. 50 actually goes into both those things. It'd be 1 over 9. And with the x's, I've got 28 of them on top and 40 of them on the bottom. So when I go to cancel them out, that is 12 extra x's on the bottom. All right, 1 over 9x to the 12th. Hope you did well with that. Good luck with your review.